Hello everyone. Today I'm going to cover a brief demonstration of the COVID-19 analysis that we conducted using the data that was published by the Korean Center of Disease Control. By the end of this, you should have context of the data, an overview of how the COVID-19 analysis kit works, and then how you can get started. For this analysis, we'll be replicating the approach South Korea took in containing COVID-19. That approach was contact tracing, pathfinding algorithms. Contact tracing allows medical practitioners to identify networks of possible transmissions early. This mindset is referred to as a surgical approach with the aim of minimizing economic disruption. South Korea learned from the MERS outbreak in 2015 the importance of a prompt response to containing these type of infections. Foreign Minister Kang said that testing is central to the outbreak's response because it leads to early detection, which in turn minimizes future spread. South Korea health authorities use data from surveillance cameras, cell phones, credit card transactions to map the social connections of suspected cases to quickly isolate and treat those found with the virus. While some might argue that this is an extreme approach, especially for Western society, nobody would disagree with the effectiveness of such an approach to minimize economic and social impacts. This approach has shown so much success that recently it was announced by Apple and Google they are building a coronavirus tracking system directly into the iOS and Android operating systems. But what Google and Apple is doing is only half the equation, which is data capture. The second is analyzing that data. This is where graph data modeling and analytics, especially TigerGraph, shines, with doing deep multi-hopping path analysis on extremely large data sets. After you start up your instance, this is what you'll see. You'll land on a home page. On the right-hand side, you'll see import an existing solution and export a current solution. This is important if you actually want to export what you've done and modified in your COVID-19 starter kit. And you want to take those enhancements or modifications and export them for a later date and then import them back, or maybe share them with other people. You can use the export current solution and then import solution on the right-hand side. Now let's go to design schema. Design schema, we're going to look at the data that actually was part of the COVID CDC data set. And this is how we modeled the data. We have patient data and a patient geolocation and infected by are probably the most important edges and vertices that we're going to be looking at for today. The infected by edge was actually created from the Center for Disease Control. So these are confirmed infected by edges. We also have the patient's route data, which is on this edge called patient traveled. And that patient traveled has a latitude and longitude along with a visited date and a travel event if it's such a thing, so like an airport or an academy or a library of sorts. The other data that we have is the infection case. The infection case is a mass event. So think of this as a church or a gym where there was multiple patients that belong to a specific case or outbreak. And what you'll see is a cluster of people around these case events. The other important aspects of this model are the city and the province and country. So all the relationships between these are located here, province and country, city and province, and then also the latitude and longitude, that's the geo stamp related to a city. Now for patient has some interesting data, including the birth year. We also have the one that we'll be looking at is the confirmed date, the release date and deceased date, more importantly the symptom onset date. And what we're going to do in the later query is actually use these dates to then find or define a period of time that we want to look at to do some path tracing. The other data that might be of interest is the state data, disease state, and then sex of the patient itself. With that being said, if you do want to add more data onto this or design the schema differently, what you can do is click on the vertices or edges to make modifications. You can also click add vertex type or add edge type. And as soon as you're done with whatever your design is, what you want to do is click the publish schema. Now with the publish schema done already, I'm not going to touch that button, but I'm going to move on to map data to graph. So these are the CSV files that we're going to be using. And all the links to these files and the files themselves will be in the kit, but there'll also be probably a link wherever this video is located. So what data do we have? We have patient information, which includes a lot of that we saw in the attributes. And that data from the patient information is mapped to the edges and the vertices of the patient. We also have the other most important data set is the patient route. So the patient route is the latitude and longitude that the patient took when they were infected. And so we'll use that actually when we want to do some pathfinding to identify where that patient went to and were there other patients that were near that patient when he was known to be infected. Again, if you want to add more data, you would go to Add Data File. And once you click Add Data File, you'll be prompted with a box to add your new data. You just click Upload Server. You can also choose if you want to connect to S3 or Kafka. The other thing you want to do as soon as you have the data, you want to map that data file to a vertice or edge. And then, of course, you can delete it. Now, these are grayed out attributes, but they allow you to do some advanced functionality. So you can do like cat functions or date timestamps or date to epoch. You just simply click on the relationship, and then what you do is you can choose the function, such as this function right here, where we actually have the gsql concat function that gives the travel event a unique ID. Now, the travel event did not have a unique identifier, and so we created one by using the latitude, longitude, and the date time. So let's look at load data. All right, we got a unpublished change for data mapping. This is okay. This is just saying that I moved some files around, and what I'm going to do is hit leave. All right, so now we're at the data. So we have the data mapped, we have the schema built, but the one thing we don't have is any data in our model. And so what we want to do is simply click Start and Load Data. By start and loading data, what it's going to do, you'll see these pending in gray eventually turn to a green, which says finished. And on the right-hand side, you'll see the edges and vertices of the graph going up. And now let's explore some of that data. So if we click on Explore Graph, you'll see some of the selections that I was playing around with. And so what I'm looking at here is that the patient with the attributes that we loaded and the edges and the vertex type of infection case. Infection case is the mass event that happened along with multitudes of patients being infected during that event. You'll see some other ones. This is a fashion company. You'll see some generic codes if they just came in contact with other patients. And you'll see, etc. If there's sort of a generic, they don't know where that person actually was attributed to for a mass event. Where they do track down people, you'll see this infected by relationships. This is a known, this person is known to have infected this person. If we actually go up that chain, we can see that this person was the first person that infected this person that ended up infecting these folks right here. Now, if you want to use the Explore Graph, you can choose different vertices here. In this case, we have patients selected. We did an infection case. Maybe if we want to populate some cities, some random cities, we can choose 5 different random cities. If we want to populate some more patients, we can choose patients. And maybe we want to put 20 random patients. So we populate some more patients. And what the Explore Graph view allows you to do is exactly what it says. And so you can click on vertices, you can double click on vertices and get more connections. You can click on a person, in this case a patient, and let's say we want to explore a certain edge towards a known vertex. So in this case, we'll choose any of these edges and we will explore towards patient. So we'll just click on the one that we want. We'll choose this guy. So let's see, this patient infected this patient. This is a female patient. And this was a confirmed date of March 23rd. and also a female patient. So with the known relationships, they have this defined as infected by. So now let's look at writing queries. So we want to take a look at some of the queries that we wrote. And some of these can be basic queries. And one of the more basic queries is really just grabbing edges. And so when we want to grab edges, what you actually do is you start at a seed vertices. In this case, we're going to start with all patients. And then from all patients, what we really want to do is grab all those patients that were infected by other patients. And so this sort of creates its own subgraph, and we're creating a couple different subgraphs that ended up sort of creating a graph of graphs. And the next one we're going to do is we're going to actually look at the patients that are infected that belong to a specific case. In this sense, those gyms. We don't want the sort of common cases what are etc. in contact with patients in overseas inflow. We want more of those cases that are pertaining to like a call center or an airport or a gym. And then the last one we want is we want actually the geolocation. In this case, we're using the out degree, and the out degree allows us to look at those connections between geolocations that are greater than one. And why this is important is because if there's not more than one person that traveled to that place, there's no reason to actually look at that as a path. What we want to do is look at the connections that have more than one person. And so what this is doing is just pulling a couple of those connections and those relationships, and then it's going to return all those edges, and that will create a graph. And so we're going to just hit run query. And you'll start to see this blob emerge. And as it sorts out, we will see a connections of connections of connections. And you start to see these red events, which are the case events. So this is the call center, and you see this big cluster of patients infected. But then also you see these little tangents that are off of those cases. And so this patient actually belongs to this big cluster of call center cases, which is actually a huge cluster. And then you start to see these patients that were at the same place at the same time, yet they aren't necessarily reported infected by, but they happen to be at the exact same place to the decimal point of 1, 2, 3, 4, 5, 6, 7. The decimal point of seven points puts you probably in approximately within a yard of one another. And so if this person and this person was within a yard of one another, the exact location, the exact time, it's probably most likely that person actually did indeed infect this person. Or at least they should be somebody that you should be watching and alerting that if this person came in contact with you within sort of the 14-day period of when somebody is known to be infectious, and we should look at those patients that came in contact with that person within 14 days and trace that along and try to figure out all the other people that person came in contact with. So that's what we're actually going to do in the next query, is we're going to actually trace those paths for an individual. And so let's go back to infection subgraph. So infection subgraph is doing that. It's looking at the symptom onset time and looking at the release date to define a window when somebody was actually infectious. And then what it's going to do is track down that potential path based off the geolocation that person traveled to. And so you also see that we used out degree in this one because we don't want, again, the people that went to a certain geolocation but didn't end up being with anybody. There's no point to report those back. And so we're going to only look at cases that have a geolocation, a latitude and longitude, down to the 7th degree of an individual that was at the same place, same time. And let's do that with let's actually choose and see if we can isolate some of these queries. So by using this algorithm, we should be able to just put in one of these and track down this cluster or these paths. especially these smaller ones. And then we'll try a large one too. Okay, so let's just choose this one randomly. So we have 2008. Let me write this down. 200 008. It's a lot of zeros. All right, let's see if I got it right. I might have missed 10. I think so. All right. So this is actually using this algorithm to determine the person that might have been in contact at the same place at the same time as this person that was infected, 200,008. In this case, we see this cluster that actually was part of that larger cluster. And we see the geolocation. So we have the latitude and longitude, which is essentially a travel event. So this person visited this place, and these particular two people actually ended up being in the same place multiple times. Now this person came in contact with 010 multiple times as well. So this created a cluster of contacts between different patients. Let's take a look at a larger one. So this is a large cluster, 41000006, who actually had a massive chain of infections. Oops. All right. So this is actually the cluster path of your patient, and so we have this patient right here, 4106. So that's the initial patient that we put in here. And you could start to see that this person had an infection cluster of visiting these. And again, these are relationships that aren't necessarily all about this person infected this person. These are looking at the latitude and longitude, the geolocation of the patients that might have traveled to the same place in the same time to determine the path that this person infected that person. And what you can start to see are these paths and chains of events that happen, and that this person who was the initial person that was infected might have infected all of these people in this cluster. With that, if you want to get started with the Graph Studio COVID-19 Starter Kit, you simply go to tgcloud.io. And then what you'll do is when you sign up, you'll choose the Starter Kit COVID-19. And what you'll do after the Starter Kit actually launches, you'll end up at this page right here. And when you end up at this page, you just simply follow the instructions that we took, and you can also get started in this kit. With that being said, thank you. Have a good day.